Today we are going to learn about CMOS Unit 1 problems on channel N-channel enhancement for current, determining ID and W by L and L, and these types of problems we are going to discuss. So I request you to go through the formulas of IDS versus VDS for NMOS and PMOS devices so that it could be easy understanding. And the problems are very simple. Just applying the concepts is just easy, and you have to by heart the formulas so that you could make the problem very easily. The first problem here we get is, consider an N-channel enhancement mode with parameters Vtn and Kn is 0.25 A by V whole square. Determine ID for VGS is equals to 5 volts and VDS is equals to 6 volts. The basic difference is that we have to see whether it is in the region of saturation or non-saturation or cutoff or linear. Cutoff linear. Okay, the first thing we have to see whether the NMOS enhancement mode is in saturation or non-saturation or cutoff. So the formula will be VDS is greater than or equals to VGS is minus VTN. So if the VDS is 6 volts, then VGS minus VTN is what? What's VGS? 5 minus 1.5 is 3.5. So 6 is greater than 3.5. So when the greater symbol comes, then it is in saturation. If the lesser symbol comes, for example, here the VDS is 3.5. For example, here VDS is 3.5 and here it's 6. Then it goes to non-saturation. Did you get my point? So when it comes to the saturation, just substitute the formula ID is equals to VGS minus VTN whole square. As we know, Kn is above given, so 0.25 milliampere by volt square. So substituting it, and VGS they have given 5 volts, 5 minus 1.5 whole square, then you'll get ID. Simply for B, you have to just understand VDS is greater than, and you just have to know whether it's in non-saturation or saturation. Let's see here, it's 2.5 less than 3.5, so it is in non-saturation. So the formula for enhancement non-saturation, NMOS enhancement non-saturation is Kn into 2 VGS minus VTN into VDS minus VDS whole square. This is the formula. You just substitute in it and you'll get the ID. So this is a simple note. For if Kn is not given, if beta is given, then to find out Kn is beta by 2. If beta is given and Kn dash is, to find out beta, this Kn dash by 2. That's the simple formulas. And when we go to VT, and these are the same simple problems, we find out it, and to just we have to note here, when assuming the simple thing is, you have to think if here Kn dash if it given, so you have to divide it by 2, so it's a beta value. So Kn dash by 2 and omega L is inside the formula. If omega L is given, so you have to keep it. If it is not given, just remove it up. Okay, there's no, if it is not given, no need to worry. If it is given, you have to keep it up. So omega by L is 5, and MOSFET VTN he has given, Kn dash is given in enhancement mode. We have to determine Vsat as required VGS. Repeat ID for, so ID is given as 2, ID is given as 0.5, ID is given as 1.5. so I'm just substituting it. So ID in the first case, ID I'm taking as 0.5 and Kn dash is given 80 micro by 2, I said that, and by 2 and into 5 is omega by L I have took in here, so VGS minus VT, so that I got VGS. The same thing I got here, so VDS I took by VDS is equals to VGS minus VTN, though I said that it is in saturation, so I just took it in this way. And this is a simple sums, and you no need to worry, and I'll be explaining the next thermal effect sums and to calculate thermal effect and COX and QX and thermal effect. These all will come under one sum. We can be clearly explained by that. And this PDF belongs to, this PDF is written by our faculty, Fani Vidyakar sir. Thank you for the PDF, sir.